Are you ready to delve deeper into the mysteries of the Van Allen belts, the so-called Bermuda Triangle of space? Imagine it's 1958, and you're part of an incredible discovery. The launch of the Explorer-1 satellite, the first successful mission by the United States into the vast expanse of space, was about to unearth a phenomenon that had been silently enveloping our planet for eons. The Explorer-1, armed with a Geiger-Müller tube, an instrument designed to detect and measure ionizing radiation, began sending back data that was, let's say, a bit peculiar. It noticed an increase in radiation levels at certain altitudes, but then, mysteriously, the counter went silent. Now, this wasn't a malfunction, but rather the instrument had been overwhelmed by a radiation level beyond its measuring capacity. A discovery was on the horizon. Enter James Van Allen, a scientist at the University of Iowa. He suggested that the silence of the Geiger-Müller tube was due to a belt of charged particles trapped in space by Earth's magnetic field. Further missions, Explorer-3 and Pioneer-3, confirmed this theory. They detected two distinct regions of trapped radiation, which we now know as the Van Allen radiation belts. The first region, closer to our planet, is a belt predominantly made up of high-energy protons. Further away, there's a second belt, teeming with high-energy electrons. These two donut-shaped belts, invisible to the naked eye, are a testament to the complex and fascinating nature of our universe. It's important to understand the significance of this discovery. Before 1958, we had no idea these belts even existed. Their discovery expanded our understanding of Earth's magnetosphere, the solar wind, and the dynamics of charged particles in space. It was a pivotal moment in the dawn of the space age, paving the way for further space exploration and research. The discovery also posed new challenges. These belts of radiation could pose a threat to spacecraft and astronauts, leading to advancements in spacecraft shielding technology, and thus the invisible shields protecting our planet were revealed. These shields, the Van Allen belts, continue to be a subject of intense study as we strive to unravel the mysteries of our universe. What if I told you that Earth is wearing a cosmic armor made of charged particles? Yes, you heard that right. The Van Allen belts, discovered in the late 50s, are akin to a protective shield around our planet, composed of two main belts. The inner belt, primarily populated by protons, and the outer belt, dominated by electrons. These belts are not random. They are formed by charged particles trapped by the Earth's magnetosphere, a region of space dominated by Earth's magnetic field. So the particles within these belts are like little prisoners, bound by the invisible chains of Earth's magnetosphere. These particles are energetic, to say the least. They are accelerated by various mechanisms, including solar wind interactions and cosmic rays. Electrons in the outer belt can reach relativistic speeds, approaching the speed of light. Now that's what we call a high-speed chase. But these belts don't just exist, they serve a purpose. The Earth's magnetic field plays a crucial role in trapping and shaping the Van Allen belts. Imagine the magnetic field as a master sculptor, molding these belts into toroidal or donut-like shapes around our planet. The charged particles follow the magnetic field lines like obedient soldiers marching along a predetermined path. The Earth's magnetic field doesn't just shape these belts, it also protects us. Without our planet's magnetic field, these high-energy particles would bombard Earth, causing all sorts of havoc. But thanks to this magnetic shield, the particles are trapped, forming the Van Allen belts. This is an impressive feat of natural engineering. Our planet, in its wisdom, has created a protective shield of charged particles, held in place by its magnetic field. It's a cosmic armor, defending us from the relentless onslaught of solar radiation. So, our planet is not just a floating rock, it's a fortress armed with a magnetic shield. Exploring space is not without its perils. One of them is right above us, circling our planet. The Van Allen belts, these seemingly innocuous bands of radiation, present a significant hurdle for both our machines and us. The belts, filled with high-energy particles, pose a real threat to spacecraft. The particles can penetrate the craft, disrupting electronics and damaging vital components. For satellites, this can mean a sudden and catastrophic failure. For manned missions, the stakes are even higher. The intense radiation within the belts is harmful to astronauts, making prolonged exposure a serious health risk. But, like all challenges, these too are opportunities. Understanding the Van Allen belts is not just about avoiding the dangers they pose, it's about unlocking the secrets they hold. The dynamic nature of the belts, their response to solar activity, the interplay of charged particles and magnetic fields, all these aspects are subjects of ongoing research. While we know much, there's still more to learn. Solar storms, for example, can cause fluctuations in the radiation levels within the belts. These changes can influence not just the behavior of particles in the belts, but also the space weather conditions affecting our planet. And then there's the mystery of the occasional third belt. Yes, every now and then a third radiation belt forms temporarily during certain space weather conditions. Why does this happen? How does it affect the other belts? These are questions that scientists are actively seeking answers to. The study of the Van Allen belts is not just about understanding our immediate cosmic neighborhood. It's about understanding the universe itself. The belts are a natural laboratory for studying cosmic radiation, a phenomenon found throughout the cosmos. As we continue to reach for the stars, understanding and navigating the Van Allen belts remain a crucial part of our journey. They are not just obstacles to overcome, but also guides to the mysteries of the universe. The more we learn, the further we can go. And isn't that the spirit of exploration? The journey to understand our cosmic neighborhood is far from over. As we delve deeper into the 21st century, the exploration and research of the Van Allen belts continue to be a crucial part of our journey into space. These fascinating regions of our planet's magnetosphere, teeming with high-energy protons and electrons, hold the keys to many unanswered questions about our universe. The dynamic nature of the Van Allen belts, their ever-changing intensity and structure, makes them a subject of ongoing research. As scientists continue to study these belts, they're uncovering valuable insights about space weather and its effects on our technology and planet. Solar storms, cosmic rays, geomagnetic disturbances, all these phenomena can influence the behavior of particles in the belts. Understanding these forces isn't just about satisfying scientific curiosity, it's about safeguarding our modern way of life. In the future, we can anticipate more space missions equipped with sophisticated instruments to take a closer look at the Van Allen belts. These missions will help us understand the complex interactions between charged particles, the Earth's magnetic field, and external factors like solar activity. They will enable us to predict and mitigate space weather effects on satellites and spacecraft. At the same time, these explorations will help dispel misconceptions surrounding the Van Allen belts. Despite being dubbed the Bermuda Triangle of space, there's nothing mysterious or unexplained about these regions. They're not responsible for any bizarre disappearances or phenomena, but they do play a critical role in our understanding of space. The future of Van Allen belts exploration is a journey of discovery, one that's bound to bring us closer to understanding our place in the cosmos. It's a journey that will highlight the resilience of human curiosity and the relentless pursuit of knowledge. As we unravel the mysteries of the Van Allen belts, we're not just exploring space, we're securing our future in it.